Alright. Here we are. Welcome back. And hello. If this is your first time tuning in, I am Ultra, and we are here to hack on, usually on Haskell. Typically on the stream we do projects, intermediate level type stuff, or like beginner type stuff sometimes. And with a focus on like just writing practical things, because I started this stream because people said like things like, you know, you can't build real software in Haskell. It's just a research language. Which, not true. We've built things like asteroids on here. We've built a library for reading Postgres's streaming replication protocol. And now, like the last couple of weeks, we've just kind of messed around with random stuff. One of the things that's pretty new and experimental in Haskell right now is adding WASM support. So be able to compile a Haskell program down to WASM and run it anywhere. That's the dream. The dream that's been in computing for many a decade, let's say. Those of you who remember the old Java marketing hype back in the day, write once, run anywhere, that kind of stuff. Always keeps coming back. But the dream is alive in WASM Town, and we are going to try this again. Tried it a couple of weeks ago. Compiling Haskell to WASM is fine. Works just as advertised once you get it all set up. So the guide for using it with like GHC and stuff is here. There's a particular branch that you can get all this stuff from, where you gotta like, because right now it's not shipped with mainline GHC. I gotta get it a different way, but this is the basic guide. Anyways, once you get it all set up though, it compiles, and the compiler works great. It runs. But the difficulty we ran into was getting the compiled WASM to run in the browser. So like running it on WASM time works, but I couldn't figure out, and I got stuck trying to figure out how the heck to get it to run in the browser. So in order to do that, you need something called, what I understand, like a WASI, a Web Application, Web Assembly System Interface, I think they call it for short. And there are a few libraries that provide this, JavaScript libraries that provide this kind of like WASI shim interface to run your WebAssembly code wrapped in. But yeah, apparently like deploying, like just to use a JavaScript library these days, it doesn't seem like anybody ships compiled JavaScript libraries. You just set up all that stuff there, and I just couldn't be bothered. What a pain in the butt. So I was afraid that we might have to do that and spend a stream setting that up. But then this was announced earlier today, I guess. Wasmer, this company Wasmer, announced a new WASI-X runtime thing. So WASI-X apparently is this shim library interface thing. It's like WASI, but with like some extensions, I guess. Some things added by Wasmer. And they say it runs both on, oh, here's the announcement, both on the back end and in the browser. All right, so we know that WASM time runs our Haskell WASMs. So WASI-X might be able to, maybe. So maybe we can get the Haskell module to run on this. If this runs in the browser, and hopefully it all works. I don't know. I don't know what I'm doing with WASM stuff. It's super confusing. And just like people trying to get into Haskell, it's like, what does this even mean? So, note to technical people, not everybody speaks your language, yo. And You gotta meet, if you want to advertise out to new people and bring them in, you gotta speak at a level. Try to avoid jargon, that kind of stuff. Just general advice. So how do I even get wasmer? So apparently I will need, in order to use WASX, I don't know. We'll need wasmer 4.0.0 alpha 0.1 to run it. Okay. Well, looks like you got it releases here. Handy dandy little curl this script and just run it. Or we can get these tar balls. Well, that sounds pretty good. Let's see, Windows, ARM64, AD64. Linux, there we go. I think that'll work for us. Okay, hopefully I don't get anything too weird in my downloads file. No, just fine. Okay. Downloads, gotcha. Okay, so let's copy that over. My downloads folder here. Not see users. Probably should have done that in the folder. Okay, cool. Ooh, right off the bat, run a WebAssembly file. Well, we have one. We compiled one already from our Haskell code. That's cool. I'm gonna make a directory for this and just move on. Okay, I'll leave it there for now until I find a better place for it. Let us... alias? How do we do that? I'm not sure. Well, I guess we can do it now. Sure. I just wanted to make a temporary one. Okay, let's fire up Emacs, my good old trusty editor. Make sure I got you, chat. Okay. So, let me just go quickly add that alias. Wasmer. Cool. Super. So let's go to my projects file and let's go to our WASM-HS kind of like test project here. Wasmer, it was, I think it was just run, WASM-HS, WASM. Okay, cool. So we got an error here. I tried to run wasm-hs.wasm, no export underscore start found in the module. And I think that's because the way we compiled it. We compiled it using the GHC backend idea of like they called it like a reactor. So it exports initialize. Let's try this suggestion. -I. Underscore initialize, maybe like this. Okay. So can't do it. That's a thing. But if we compile it with the right options, so a non-reactor one should work just fine. Let's go to projects. And we'll go to WASM-HS. And if we look at, I think it's the Cabal. Yeah, this mexec model equals reactor. Yeah, so you have to go to this repository here in order to get all the Haskell compiler that has the WASM backend. But if it's not reactor, it's something else. Yeah, so if we want to run it, I guess with wasmer as a command line, we need a start function. Okay, so if we want to do that, we wanted to make a WASM command. Maybe the command is the default. So I guess we just omit that link type flag. And we'll create this command. And Cabal builds. Oh no, we need a special Cabal. Yeah.
WASM-32. Oh, I can't find it. Why not? All right, I need to source this in order to get all that stuff on my path. Cool. Probably don't want that. Probably want this. There we go. This. Oh, sweet. Okay. Okay. And now, WASM time. WASM. Do we have a start? We don't have a start this time. So. Oh, okay. Maybe we don't. HS. WASM-32 quality wall list units, was it? No. List bin. Okay, that. I think that's what we want. Try this now. Wasmer run. Wasm HS.wasm. No export start found in the module. That works with WASM time. WASM HS. Wasmer doesn't like our module. Found initialize. Let's try it with that. Nope, still won't work. Okay, maybe maybe we need to learn a little bit more about Wasmer, how to use it, that kind of stuff. try the C integrations. Okay, so set up your C++ to build C applications they use the WASM runtime as a host or guest. Well, for guest WASM modules, you'll need a C compiler. I don't need to compile with WASM. I just want to use it as the runtime. Is that possible, or is I misunderstanding what this whole thing is for? Yeah, I don't need WAPA. I don't even know what the heck that is, but apparently this is some kind of package thing. It can also run standalone WASI or scripting WASM apps. Deploying WASM run to the WASM file. Okay, so it doesn't work with our Haskell module. Unless there's maybe some flags or features we could use to configure to make it kind of tweak it and work with our particular module and the way it's compiled by GHC. It has a helpful inspect command, it looks like. WASM cache, WASM compile, WASM config. So let's try inspect. Let's see what it says. I misspelled that. Wow. Okay. So it correctly figures out the type. So it parses and everything. WASM 421 bytes. Functions. Initialize is still being exported. I was kind of expecting start, so maybe we're still not compiling these properly. It's not shared. Labels. Okay. Good. So let's double check, because we should have the start function there. So we should probably make sure that that's there for sure. For surezies. Besides WASM, the piece of extensions are used, the feature flags are used globally in our WASM capability. Pass that GHC configure type, WASM CG, whatever that is. They make use of the features. The rationale of post-MPP WASM feature. Supported by default in the latest versions of Firefox LLVM supported stable. List of WASM extensions we use.
WASM supports all these. We should be able to use this. Should be able to run this. Multi-value reference types, import, export, import only operations, and such stuff. So we know it runs on WASM time. For sure. How do I get it to export the start function and make this additional stuff? I want to create a reactor module. I want to create a command. Okay. Well, maybe we just put command here. Let's try that. Over. Inspect it. Still just initialize. So maybe that didn't really do that. And it should just be like hello, blah blah blah.
Salvation code.
Okay, well that's not quite working. Let's see, is there an example? There's a bigger story left to tell. Sunk way down low in Tokyo, in the lowest level of this hell. Transmissions coming from my savior, receiving in this lowly place. They are analog and digital, in the guiding me through time and space. Salvation code. very good documentation on WASM at the moment. But let's figure out this part here. Documentation doesn't really say a whole lot about how to compile a command. Reactors. I figured if you just omitted the flag. How about we do it this way? Let's do it like the example of name. Let's turn around. Hello from Haskell. Put that into hello.hs. So there's hello HS. And we will WASM-32. We'll invoke the compiler directly, just like they do. Example. Just -o WASM and wasmer inspect hello. This one does have a size, so it must be something with cabal flags. Let's try wasmer run hello WASM. That works. Okay. So if we get the cabal flag situation figured out, how do I use WASX now to run this in the browser? Once we can get that going, then we're golden. Things will be good. Life will be worth living. It'll be full of color once more. Okay. Hopefully this will work. Question marks? What do I need WASX libc for? This fork of WASI libc extends libc with missing functionality needed to build complete useful applications, in particular to incorporate these additional extensions. Full support for efficient multi-threading. T-threads support. Full support for sockets. Directory support. Set jump on jump support. Also support being subprocess waiting. TTY support. Asynchronous polling of sockets and files. Type and event support. DNS resolution support. Blah blah blah. Okay, so like some of these things it seems like we need from the Haskell side of things. Like, looks like GHC is also using WASI libc. So maybe we already have this and it's fine. We just need to run it. Which it runs locally here, but how do I deploy to the browser? Down to get down, you know what I mean? Run, self-update, validate, blah, blah, blah. Create exe, don't want that. No. Compile, no, I don't want to compile to a native, into a binary or anything like that. Okay, WASI-env is a tool to make very easy to compile different programming languages to WebAssembly. So you can run your programs in the browser or even in the server. This is what we're here for, right? How do we do WASI E and V? Okay, I don't want to just run it with wasmer. How do I do it in the browser? Okay, WASI in the browser. Okay, so in this introduction example, we'll develop a browser-based application using the following call chain. JavaScript, WebAssembly, native OS function. Okay, in this case, we'll invoke a simple WASI module that does nothing more than writing hello world standard out. That's exactly what we're starting with here. Okay. However, interaction with file descriptors such as standard in and standard out is not normally possible for a WebAssembly module, as we've learned, since this type of functionality belongs to the underlying operating system calls. We understand this. Therefore, we must make use of the following two packages. wasmer/WASI, set up with JavaScript polyfills to bridge the gap between the black box world. I also learned this last time we tried this. And wasmer, WASM-FS. WASM-FS. Okay. Oh no! God damn. More web front-end build toolchain packaging bundling crap we have to install. Well, if this is our life, let's do it. Let's live it. Okay, well, hopefully if we follow this tutorial and we get this all building, like, with this bundler, it's gonna work this time. Let's check it out. Okay. We're already in our directory. npm init, sure. Sure. I don't know. No, I don't want any of this stuff. Yeah, it's fine. Okay. For the purposes of, so we have done npm init. For the purposes of testing, we need to install both the Parcel bundler, Parcel plugin static files copy packages. Okay. These packages allow Parcel to serve our WASM files as static assets. Gotcha. Knew it. We would not be able to get away from JavaScript bundlers in order to do this. There's just no way around it. Okay, so that's running now. That's going to do, we're going to create a bare bones index.html file that contains nothing more than the request to load the JavaScript file index.js. Good times. We have an index.html, we already do. Let's open that up. Let's get rid of all that. Almost all of that, actually. To our body. Well, just like that. Okay, cool. Now we'll create index.js and have the following single line of code. Okay. I'll just press this handy dandy clipboard button. It'll be super cool. we got a build error with npm. Surprise, surprise. Chip error. Oh, good times. Good times. Oh, look at all those errors. Oh, God. Lovely. No longer supported. Deprecated. Oh, these warnings. And, oh, so good to see. So nice. Alright. Let's blow away our node modules. For real. And we'll try it again. Maybe? Who knows? No, doesn't want to. Okay, netdb.h file not found. Good times. I think I'm missing some dependencies or something here. WASM API only supports WASM 32, doesn't support WASM 64. It's fine. Why are you trying to install WASM 64? Why are you trying to build that? Gosh, stuff's terrible. Hey, I do not like using it very much. Okay, so I guess that means it's trying to build something we don't want it to build. Parcel bundler. Multi-core, production green, notification board. Cool. Make these websites a little too pretty. I think I already have Parcel, right? We're trying to install Parcel bundler. Here's the tutorial. Hey, we're whimsically made. What's going on? We're trying out WASM that was announced today to run our Haskell compiled WASM module. That's what we're doing today. And we can't escape trying to set up JavaScript bundling tooling to get it to work, because that's how it goes these days. So wasmer can run, it looks like, our Haskell modules, which is good news. Yes, we already have that compiler. It's very experimental, but it's available. So Haskell will eventually, once it gets ironed out, have a binary release that compiles Haskell code to WASM. So that part works. You can get it here. From Glasgow GHC WASM meta repo. And that is where you can get it and set it up. Stuff. It's all good. We have compiled a Hello World with WASM module that we can run with wasmer. And this will just run it locally. Hello from Haskell. That was compiled from this little program. No biggie. So that's good. Now we're just trying to get it to run in the browser. Currently following this amazing tutorial and from wasmer, but I guess their tutorial's out of date because JavaScript, moves so freaking fast that none of this works anymore. Which is super cool. Because if you go to Parcel bundle, the Parcel bundler package on npm, it's already deprecated. Hopefully, I don't know where to get the v2 on the non-deprecated one. Yes, it's so cool. So how do I get v2 to Parcel.js? How? There's so many options here, people. Getting started. Scratch, okay. So I've already done this part, so it should be v2 Parcel, right? Okay, let's just save dev. I maybe just installed it globally with -g. Just save dev and see if this works. Maybe we're gonna have to follow our own tutorial to get this all going. Okay, that seemed to have compiled and worked and all that stuff and installed it, right? You probably don't want to see this starting this from scratch project. Whatever. It's all good, I guess. Looks like 0 vulnerabilities. We can fund some things. Awesome. Probably should do that. We do rely on open source quite a lot, and it's underpaid in a capitalist society, so support them. However, let's. How do I set up now that Parcel is installed? Let's create some source files for our app. HTML file is a good place to start. Parcel will follow your dependencies. Okay, so we have this HTML file, or something like it anyway. Has a development server built in, which will automatically rebuild your app as you make changes to start your own Parcel CLI. So npx Parcel is our index file. Okay, thank you for the update. Hopefully this is better. Let me know how it's going there. Pacha. Is the mix better there? That's too quiet. Okay. We'll kind of bring it up to the middle. Alright, so hopefully that's kind of halfway in between. Okay, so we got a web page being served with our bundler. Let's check that console log. Okay, so there's our JS. I am working. Hello. Alright, that's this here. Okay, let's see. What else do we need to do next? We got that going. So the basic structure is working, set up correctly. So we need packages wasmer WASI and wasmer WASM-fs. Okay. Hopefully these aren't outdated and deprecated. Okay. That looked like it went well. And I've got our own WASM module. Yeah, we're good. And check my loudness measurements on time. Okay, good to know. Alright, well, I can adjust my levels only so much here. Hopefully this is a little better. I'll have to figure this out sometime. Thank you, Whimsically. Okie doke. So we have a WASM module to load. Now we need to change the contents of our index.js to implement the required functionality. Okay. Okay. Okay, let's see if we can copy this file in and just kind of tweak it to our needs. Get rid of this console log. Copy. Paste. So if this works after the tutorial, that opens up some new avenues, and I want to see how far we can take this stuff. Like, can we get some DOM action going and be able to create some DOM nodes from Haskell? Will we be able to use things like the canvas, WebGL, that kind of stuff? That would be super sweet. So it doesn't want to copy everything here from this. Okay. Try that. Ka-chow, ka-chow. Well, thanks for tuning in, Whimsically Made. Yeah, usually Tuesday evening. I'm in the Eastern time zone. Tuesday evenings around 10 after 8 is when I start, generally. But I do back up these to YouTube as well. Most of my streams, not all of them. These ones I haven't really been doing, these kind of like interim between project ones. My stream, my channel on YouTube is this one here, which I'll paste in channel. So that's the stream from when we last tried to learn WASM with Haskell. It didn't go very well, but I put it up there anyway. I might put this one up. It seems to be going a little better. Okay, so we just have to tweak this script to load our WASM file, which is hello.wasm, I believe. Okay, so let's try and understand what's going on here. This is bringing in our modules. I'm guessing because we're using this bundler, it's reading this file in and compiling everything so that it works actually in a browser. WASM file path. It's all commented there, so that's pretty straightforward. So this is kind of our shim fs module, and hopefully this WASI interface here has all of the functionality that Haskell will need for its runtime to work. Okay, so let's start WASI task. We'll run our WASI module. It's okay. Fetch our WASM file, we await it. Yeah. Okay, so we have to be careful. I guess it sounds like this comment is saying we have to be careful about marshalling type between JavaScript and Haskell. Not everything lines up one-to-one. That's pretty standard stuff when you're working with foreign function interfaces. So we'll have to watch out for that. Let's see, instantiated. Okay, the WASI.start. So it's going to call our start function, I guess. Get standard out. And then document.write standard out. Okay, so document.write should write that out to the DOM directly. So we should see the standard output. And then whatever our Haskell program dumped out. If this worked. Okay, so let's run our file here with Parcel. Hopefully that all works. We're getting an error. A build failed. Transformer.js. Browser scripts cannot have imports or exports. Okay, so my assumption there was quite wrong. Have the type equal module attribute to the script tag. Okay. That's probably right. This is clearly, this tutorial is just out of date. Too old. Yeah, even in the Parcel modules even recommend this here. So let's go and modify this. Yeah, here. Supposedly this will auto reload for us at some point. That kind of work, maybe. Sort of. Okay. Failed to what? Failed to resolve bindings browser. Okay. What's that used for? It's used only there. Okay, so it seems kind of important. Tutorial's just super out of date. Okay, npm WASM. Sorry, wasmer. Okay, ciao. Maybe we're not supposed to use it like this anymore. Try commenting that out. Okay, this is still garbage. Okay, Parcel core failed to resolve wasmer wasm.js underscore big.wasm on this. What am I supposed to do? I don't know. This is in a library. In a minified JS file, so I can't even go in and fix it. Fix your code for you. Can't. It'll do that without doing a whole bunch of other stuff. Okay, so what does this mean? I guess this kind of probably seems to mean that getting WASM to run in the browser sucks. Like, all of this just to get it running in the browser, and it doesn't even work yet, still. So, I don't know, Wasmer, you made a big splash about WASX today and your new stuff, but you gotta put some polish on this stuff, you know what I'm saying? Making software universally accessible. Sure. It doesn't... It runs locally, which is good. Like, copy and run this command. Who has IWR? What even is that? I don't know. Doesn't work on my system. Okay, so, and then running it in the browser. The tutorials for doing that don't even work anymore. You gotta update those. This is all out of date. This doesn't work. Okay, let's look at transforming WASM modules that require transformations. What is even this? I don't know. I have no idea. Let's find out. The final code for this example will be found on GitHub. Irrespective of whether your JavaScript code runs on the client or the server, the statement shown below to transform a WASM module will always be needed until browsers land big enough to support in WebAssembly. Please repeat the step-by-step instructions given in the Hello World example, but with the following changes. Okay, we haven't even gotten the Hello World to work in the browser yet, so pretty sure that's not going to be this important yet. Okay. I can't. What are we gonna do? What are we gonna even do with this? Yeah. Maybe, did we just maybe not? Oh, maybe when I blew it away, I forgot to reinstall it. Wait, maybe that's it. Maybe I'm not, maybe it's the problem. This happens. No, it's still not. Well, that's too bad. That doesn't work. So yeah, I think what we need, if this is going to become a thing in Haskell land, where we're going to be able to compile stuff to WASM and then embed and then run our Haskell programs in the browser or in the server using this stuff, the front end story needs a bit of work. The browser story needs a bit of work, and maybe we can cook up something in the Haskell community to do it. To like build our own WASI layer and get all this, build all this stuff together and maintain it all, so that this is as easy to run in the browser as it is locally, because it works locally just great. Which is super cool. But yeah, the browser, the front end part, folks, is just, it is what it is. Alright, I don't know what to do about this here. Like, I can't really do a whole lot about that. So, it's too bad, but there you go. We tried. Haskell running in the browser using WASM. Maybe not yet. We still got some time on the stream though, so what should we do? I'm thinking I've got a bug to fix in one of the libraries we actually wrote on this stream, so why don't we fix that bug? Okay. So that's under GitHub, Agent Ultra. Replicant. postgresql-replicant. That's what. So this library here connects to a Postgres database and can read as a user with replication authorization to use the replication features, and can read the write-ahead log, the streaming replication stream, the replication stream. You can read the replication stream, and you can write a little Haskell program that can listen to changes to your database in Haskell, which is super cool. It's fun. It's neat. It's a useful thing to have. There's a bug I discovered a little while ago where certain messages in the protocol don't send the next LSN, which is a Postgres thing. That's the log sequence number, where these kind of like informational messages don't send the LSNs. It doesn't affect the write-ahead log, and so you get this error. So it can be useful to have when you're writing applications using this stuff, to be able to emit these messages, because they might be like informational messages about like transaction progress and some kind of long-running sort of process, like some kind of saga in a distributed system kind of thing. They can be other kind of metadata about what's going on, and you can emit them using this function here in Postgres outside of a normal transaction. And I believe those will get sent over the wire, and the library won't parse them. So I'm just going to update my stream title so we can let people know who are maybe not tuned in yet. PostgreSQL. Streaming application. Okay. So let us go to our repo.
One night I had a dream, right? What if there were this club where no Hasbro kids went, that played half dance music and half indie, whilst people went mental under a sea of lemons and limes?
Close all this. Don't need that anymore.
Well, this is what I did. Firstly, I had to get a venue. I checked out loads in Sheffield, some good ones and some not so good. I'd even call them crap. But I decided on this underground club. It weren't underground because you didn't know where it were. It was underground because you had to go down some steps into it. It felt right.
I was learning something weird.
Next up, I had to get somebody to give me an hand.
Abort that.
They needed to be good. So I got this mod called Joey. I picked him because he hated mods even though he looked like one. I wanted it to be a cool club, like I'd been to in Paris and London years ago.
Okay. Gotta make sure my branch here is up to date.
Bully boys who drink shandy. Can I say that? I just have.
Okay, so with this library, I think I've already got Postgres running.
I've never seen a dream come true.
Status.
There's people I've never seen before. We're queuing the door to come in.
Oh, sorry, it's the other way around.
I was watching in slow motion as old Misfits and Mavericks came in. They're all aghast but old lemons and limes that were swinging at the time of music. They couldn't get their heads round it really. Slowly, dance floor were busted. Everybody dancing the lemons and limes as juice drips off onto this sweaty
Okay. So, okay, let's start Postgres then.
They were on, but they didn't care.
Okay, so the server's not up. Now it is. And build everything.
Everything was cool. I'd been running night for about a year. That's when
Okay,
it all started to get a bit
and
down.
what
You see,
version
I'd
are
got
we
this whole
running
new
default
circle
here?
of friends who weren't really my friends. They were more like enemy within, and they made me look at myself.
Oh, I got 14 and 15 installed.
First me, and then club. I ended up buying a one-way ticket to Mexico, but I didn't go.
Okay, SQL Postgres. Leave on now. Okay, some Postgres nonsense to set up here. First, for some reason, okay, 14 and 15 is online. Maybe PSQL is an update. Yeesh. Type here. Oh. Maybe I'm trying to connect with PSQL's default for 15. Maybe we need to install one for 12 or 14 or whatever I developed it on last time. Okay. Can't be the only one though. That's version 15. Okay, let's run the Postgres user quickly for a sec. So connect there. See if we can root 14. And maybe 12. We'll just leave 15 on the system. Okay. Okay, so 15 should be online at 543. Okay, so we might just have to set PSQL support. Yeah, dash Oh, JK doesn't exist. Okay. And then I gotta set up my user. Okay, fine. Gotta throw this again. Create user. And create database. Grant all on database to jking. So I'm going to do this all on jking. Alright, last right one. Grant all on database jking to jking. Great. And users. So we have to, in order to be able to use replicant, we have to set up the user and grant them the role, a special privilege called replication. Alter role is what we need to use for that. Alter role with, okay, cool. Replication. There we go. Okay, and I think that's all we need to set up for the user. Database stuff, so we can jump into that. Okay, cool. Now we got our database. Super. So let's do this in, let's jump out of PSQL here. King. Database to king. Post, 5434. Set it to issue support. No place like that. Okay. Well, we'll just use yes, go on. It's there. 5434. Okay. We'll create a table. Call it create table test user. Okay, and in that table we'll just have like ID is a big int generated as identity, and a name which is just be text that is not null. Good syntax for that. Postgres generated always as identical. Okay. So we have to. What am I doing? I don't have permissions on the schema public. I just don't have the right roles. PSQL. Alter role. Of course, you don't actually want to add a super user role if you're doing this production system, but I'm just doing something like that. With super user. It's funny that it's like alter user for that. Anyway, whatever. Quirks. Back to creating our table. Okay. There's our test table. Now we need to actually change the configuration on Postgres. PostgreSQL team name, and we want to edit the postgres.conf file to enable wall replication. Wall level. Change this to logical. So the library only listens to logical replication. This just made like parsing stuff a lot easier. Also, logical replications, if you're writing a library like this or doing stuff with the replication streams at this level, you basically want to use logical, because the other one is a binary protocol, and the difference between the two is that like the binary one is transmitting data so that you can replicate the state of the disk itself and on another remote disk on another machine, which is useful for a lot of replication purposes, but we're trying to do things at the application level where we want to know what statements have been run, what they were containing, what parameters they contain, and that sort of stuff. And so logical is where you get that kind of thing. We can see what inserts were run, what deletes were run, what updates, that kind of stuff. So we have to reload Postgres' configuration like that, with that, so reload. And so we should be able to connect to PSQL now and show the wall level setting as logical. It's still on replica, so the reload didn't work. Let's just restart the server whole hog. Sometimes reload, these service scripts don't do the thing I think they do. Restart. There we go, logical. That's what we want. Okay. And we have to update our hba.conf. The default configuration for this is pretty good. It's a good default, but we need to trust local connections. So on 107.132, we're just going to trust. I guess maybe that's a thing this library could support better. That would be a nice feature to have, is to support like these different authentication types. For now, trust is what we recommend. Oh yeah, and we'll restart that again. Cool. So we have in this package a test program that can get built when you run it. Package.yaml. Executables, the replicant example. That needs some environment variables to be configured as per the README. Did I not write out how to set that? Okay, well, these are the default configuration settings. We just need to set PG user, database, host, port, maybe that one, 5434. If you don't specify slot name, I think it will, if I recall, the library will create one for you. I think that's enough. Okay, so those are all set. Now we should be able to run replicant example. Oh, right, we need wall2JSON for that. For Postgres 15. Search wall2JSON. Oof, it won't work with 15. Wall2JSON, at least in this package, only has 14 space. Unless I haven't updated my package indexes in a while. That could be the case. Fat fingering some of that tonight. There we go. Might have been a while. Looks like. Okay, now still just 14. So maybe setting up 15 was a mistake. We should have stuck with 14. Spoo. Okay. get rid of that then. Well, we can just install 14. Let's just pick 14 has the same configuration. It does. Okay, good. And SOM 5433. Super. Okay. Okay, so we already have a test tape and stuff already set up. Okay, so then over here, let's export back PG port to be 5433. Okay, we need a well-to-JSON to be installed as well. Okay, let's now add postgresql 14 wall-to-JSON. So this is a plugin that gets installed with Postgres, that Postgres will load, and just basically encodes the wall stream, the normal wall stream, which is, I believe, a binary format, if I'm not mistaken, and just formats it as JSON for you. Spits that out. Okay, so the example should be connected now. If we just try to insert into our table, just ID test who and price count. Okay, and foo data type. What is that? As bar WASM cuts. Okay. So we should be able to insert into test types. If I can remember the thing, goes to the string brain. Testing types. Okay, test and price count. So insert into testing types, test and price count. Some values. We do fuzz and 23. Okay. So we inserted that into the database, and because we already have, like, in this database, the replication slot all set up and everything, this is what we get on the Haskell side. We get this change received, and then we get the change delta. So what was involved in this transaction was this statement here. Had the column types, integer, foo and bigint. Kind was insert. The schema was the public schema. Column names was ID, test, and price count. The order of these lists correspond here with the column types and column names. Wall-to-JSON, I believe, is the reason why they spit out the way they do. We could probably do something where we could make a map out of this to make it a little bit more nicer to work with, but that's just how it is for now. Then you get the table, the testing types, column values, that were inserted, and then the change next LSN. So log sequence number. This is kind of important, and it's kind of a limitation of the library. You have to remember when you're writing your Haskell programs using this library to always return the change LSN that gets sent to us as the last step in your handler. I'll show you what I mean. So this is our main program that does all this. Sets up the library, and creates the logical stream connection. And then each change, this function gets invoked with the change. So we print change received. We print the JSON encoding of the change. And the last thing you have to do, what you have to return from this is the next LSN. The reason for that is so that the stream is reconnectable. So if this library loses our connection, if we lose our connection to the stream, we can reconnect and start from the last message that we processed, like our program processed. So that's kind of nice. And then some exception handling. And that's it. So now let's invoke the bug. Now that we're finally here. We're not in a transaction. So I should be able to write this. And we should get that error. There we go. Something bad happened. Replicant exception. Handle replication row. Error key next LSN not found. That's the error message there. Alright, so it did send us something. We just we were expecting an LSN there to parse it. So let's create a branch off of master. Ooh, we updated stack resolver too. Cool, good to know. So create a new branch. We'll call it starting at master. And we'll call it fix/28. Okay, so the error I think comes from database, postgresql-replicant. And I think it's under protocol maybe? Yeah. Right here. Handle replication row parser. So we get to this branch because we tried to decode a change from the body of this xlog wall data of the xlog. So this xlog is just the raw blob that's sent in from Postgres as a byte stream. So you tell us as byte stream, some sort of binary data, some sort of bytes. Those bytes should be in JSON. That's what we're parsing here. The change is expecting some fields. Let's take a look at what the xwall log, that blob is. Before we do on this. We can add some cute little debugging. Import qualified, debug trace as debug. handle our replication row right up here. We'll just debug.trace. I think we might have a showing sims for it. Hopefully we do. Okay, and then get our builder going. Close builder. Oh, because we changed when we merged master, we changed the stack thing, so it's going to take a little while to build. Oh, it's going pretty fast though. Hopefully that does build. So when that does build, we should be able to, if this does compile, we should be able to get this debug trace to show us what is actually being sent. And then we should be able to change our definition of this type here. So hopefully be able to parse it. So hopefully it's still JSON, it's just missing a key. I think that's probably what's happening here. The definition of that type is a message. So it's expecting this field to be sent. It has to be present in order for it to parse. If it's not there, it can't. So I'm thinking this needs to be, in certain cases, a maybe. I think this basically needs to be a maybe LSM. So like when it's not present, it's not there. We might want to have some assertions or make this into a different, like we might want to wrap this in a sum type that can handle the two different cases, so we don't have to mix them up. Because these informational messages, I don't think they're going to include anything in change deltas. It's just going to be like a string of some kind. And the reason why I think that is because you can read all about the replication protocol stream and streaming replication protocol in Postgres. In the documentation. Alright, so if you want to go ahead and try and write your own library that does this, this is where we started when we wrote this library, and where you can start too. So the message flow, the message types. Documentation, this is the this is the front and the back end, like low level, wire level protocol. Individual messages are described in this section here. These are all the different message types that we parse. We just parse the JavaScript versions of this. So we use multi-JSON. But a part of the library had to implement some of the wire level stuff. For getting the xlog messages that all of the wall JSONs are packed in. Some of these are information. Okay, you get your xlog data. So we have to parse these xlog data things. And the part of the wire protocol that Postgres uses for transferring files. Copy protocol, let's call it. So, yeah, we're almost done compiling. But the different message types, one of them, keep alive messages, xlog data. We want the messages that would be like inside the xlog data, like the actual wall messages themselves. We can also look at the wall.json documentation too. Because this is ultimately where our parser is kicking in and getting the error. Yeah, so I suspect we're getting a structure like this probably. So I do think we have the message type parsed as well. Yeah. We do. We can handle that part. Okay, so we finished building. So let's run our example again. So we're trying to parse it again, but it's not working. Yeah, so here's that xlog data with some of the wall information, like the LSN offset, send time, and then the wall log data. This is the structure we're interested in here. Change, kind, message, transaction false, prefix test, content, boop. That's what we're sent, but no LSN part. So we get change next to LSN, but no. We get change. Okay, so deltas comes from the keyword change. So we're missing this next LSN keyword. Looks like. Which is why our JSON parser is failing there. Alright, so if this is what I'm not super sure the best way to approach this. Okay, because if we make this a maybe LSN for here, all right, now we have another case. We have a case where, well, this type would admit a value where this LSN could be set, could be just some LSN. And the change deltas could include this message kind. This transactional false message kind. Okay. This also could admit a value where this is nothing. And the change deltas is an insert statement. That would be bad. Because the user has to be able to return this LSN in their callback in order to update the stream state and replicant. In either of those cases. So we have to be able to figure that part out and what to do there. The other approach to this is to not admit this type, or admit these possible cases at all, and figure out a better representation for a change where we have this other case completely separate. Alright, so we can parse this out, and we know we can give it a specific type. And it's separate from the regular changes where we have LSNs. And this would force, in either case, this does force us to change how we handle the I'm trying to remember which module it is in. With application slot. I think that might be just up in here. Okay, so yeah, with logical stream. And so you get an IO LSN and an IO unit. We're kind of relying on the user. The library is relying on the user to return that LSN when we call their callback. We get the replication slot, we start the replication stream with CB, the callback. Here. And start replication stream takes that callback. Where does it get used? I'm jumping in. CB. Alright, so this is the copy protocol handling here. And we raise two threads, the keep alive handler and the handle copy of data, which gets past the callback there. So it's handle copy of data. We get a row, handle replication row. Callback. And this is where our error is coming from. Okay, so then, yeah, and so this is where callback ultimately gets called here. When we get some wall log data, we get consumed LSN. So this tells us that once this callback is run, this is the next log sequence number. This is the log sequence number we've consumed. So the client has handled this data, has done what it needs to do with it. And then we update the wall progress. We tell the Postgres server, okay, the callback is run, the data has been handled by the replication consumer. You're free to proceed to sending us more, to update your state about where we are in the stream, basically, where this consumer is in the stream. And that's pretty much what it does. So that if we reconnect this replication, if we lose the connection to the replication slot, Postgres will queue up data in that replication slot for us until we reconnect. And then when we reconnect, we can tell the slot, like, restart us from here. then it'll start replaying those messages for us. But if we change this to maybe LSN now, we'll end up having to change this code here. And there will be cases where we have to update while progress, and I guess a case where we just don't. So that's probably not so bad. Actually, that might be the easiest way to do it. But the... Yeah. Okay, well let's see where this, let's just make that change and see where it goes. Maybe it'll be fine. Anyways, the reason why I'm kind of like meh about it is because like I prefer to prevent our code from ever having to handle a state that doesn't make any sense. I think the Haskell idiom is to make unrepresentable states unrepresentable. So that means like don't try to avoid including types that you'd have to have error cases for. Like we shouldn't have a change where the next LSN is nothing, and this change deltas includes an insert. It just shouldn't happen. Shouldn't be possible. So we can bake that assumption into our code with our types, so that can't even happen. But I think that's going to make our parsing quite tricky to do. But it might just be the safer option. So why don't we stick with the idiom there and see where that takes us? Okay. Call it. What time do we got? 10:16. We're running way over time here, but I'll change payload. Message payload and something for what is it really? It's like a non-transactional message. Otherwise, we have a change message. Okay, so we need to put something in this hole here to finish this definition. Information. We can always, rename this before we get to committing it. But we don't have an LSN in this case. We just have a change with a list. And we should have just kind message in it. Like it should be wall log data, but it should just be this case here. In fact, maybe just message. Something like that. Turn on our file watch. Oh, sorry, not make stack. And look at the parser for message. Okay, so it handles the kind key. Will fail if it's not message. Transactional, prefix, and content. And let's see, we get kind, transactional, prefix, and content. So yeah, this should just be a list of message that we should be able to get there. It looks like it's in a list, so let's make it a list here too. Alright, so then we need to derive some things. We need to give our JSON instances. To JSON with our default options should be fine. And then from JSON is where we need to parse it. Object. O, view, okay. So yeah, then we just need messages. That's going to be from change key. And that's it. I'm going to stick with this here. Okay, and that should compile. Quite. Oh, right. Got a hole here still. This strict, and then we need generic show. What else do we need for change payload? I think that's it. Oh no, we need the JSON instance for change payload itself. Okay. To JSON, change payload, generic to JSON with default options should be fine, and from JSON, change payload. That's right where our parser gets a little tricky. So we go with object again, change payload. Okay. So here is where we're going to have to figure out how to differentiate between the two cases when we run our parser, and they have to be mutually exclusive for this to work. I think the defining factor is going to be the presence of that change LSN key. Right. And I believe there's syntax for this to be optional. Things like this. where we want that key. And I think we can maybe discriminate on it. Maybe change LSM. Nothing case, we're going to do something and just LSM. Sorry. I think we're using data strict on here anyway, so it's probably just overkill. Okay, so then we just have our holds. This. Okay, so if we do parse this properly, if we do parse this, we return and then we need to get changes. then we get this type error here. Consumed LSN where we thought we would. 140 here. So down here we have to handle that case. So callback. First problem is callback takes change. So we have to make it take change payload. Which is going to propagate up a bunch of places because we passed this down quite far. And then of course our house might change a little bit too. Okay, well that does all compile too. Our app main didn't have to change because we don't actually investigate it, we just encode and print it out. So we should be able to see this in action now. Okay. Change received. And then we segfault. Why? Why did we segfault? Interesting. That's kind of unexpected. Segfaulting. Ooh, okay. Interesting. It, Might be this line here. Although why it's segfaulting, that's kind of weirding me out a little bit. This line is wrong now. It's kind of interesting. Now, that's weird. That this would compile successfully. Shouldn't be a thing. Okay, let's look for change left LSM. expect this code in app in main here would have to pattern match on change. No. Yeah. Should be change payload of information and information message, right? And change message. This is kind of where we need to figure out what we return in this callback in the information message case. So protocol, we say IO LSN. This should be like IO, maybe LSN? Probably what it needs to be. So let's do a string. This is maybe LSN. So become pure just. That. And nothing. Okay, and then we have to update this. So consumed LSN now is a maybe consumed LSN. And in the just case, update wall progress. Otherwise, do nothing.
Everyone has had too much of now. From megacities like Central to the vast and desolate outlands. Nobody wants more of it. How it used to feel is what the people want.
Replicant. Time modular interface is going to change.
Retros. Remember
So this is why we're probably going to bump the minor version of the library. This is change payload. And that's why I made that change. Get type error. Okay. Good. And then the message.
Retros. Remember treasures of the forgotten past.
Okay, so now app would have to also import change payload. Or replicant has to be exported. Let's just have that. So our module interface is going to have to re-export that. So so we need change. We're going to need information. And we're going to need change payload. So we all compile again. We're good. Cool. Now, no more bug. So we reconnect, replay the stream. We're good. We're back up to speed. Everything's fine. We even parsed our information message.
From mega cities like Central to the vast and desolate outlands, nobody wants more of it.
Sweet. So now we should do a test.
And rememory offers us exactly that. Rich
There we go.
rose. Remember
Awesome
treasures
sauce.
of the forgotten past.
Okay. So that fixes the issue. Let's put that in commit. We're gonna have to do some other cleanup stuff on it to actually ship this. But that fixes the issue. So we're gonna call this add change payload type. This type parses the two cases of messages. Receive cases of wall messages we receive. Informational messages emitted by the Postgres function. PG logical emit message and emitted outside of a transaction. You can also emit them inside of a transaction as well, which I think will be part of that transaction and will be a normal change message. And change messages containing the usual transaction changes. We can tell these message types apart because the page messages have a next LSN key that we need to return to the server. Informational messages are purely for information and have they don't affect the replication state, so they don't have an XL log sequence number. They're not part of the log stream. I'll push that up. And there we go. So again, the code for this library that we're fixing this bug on is at agentultra/postgresql-replicant on the GitHubs. That concludes this week's stream. Thanks for sticking around. We ran a little over time, but you know, it was cool. It happens. And yeah, so if this is your first time tuning in and you haven't followed me before, I do these streams once a week, usually on Tuesday evenings in the Eastern Time Zone at about 10 after 8. If you want to get notifications when I go online, because sometimes I do surprise streams, you never know. You know, if you're watching on Twitch, you click that button and it'll subscribe and all that sort of stuff. And if you're in a different time zone, you're watching on my YouTube channel there, you know what to do there as well to get updates when I post new videos. So, that's that. May all your monads be free, and may your types always check. And don't forget to check out our Discord server as well. You can find that by following the link above. There's a channel there where you can tell me about your cool projects. We can discuss anything you want to discuss on the stream that you saw. If you have any questions, show your projects, just chit, chat, do all that. You know what I'm saying? So, there you go. Thanks for tuning in, and we'll see you next week. Take care.